This is integrated 3. It's problem 6-54. It says a copy machine company advertises that its copiers will make at least 25,000 copies before requiring maintenance. A consumer research group tested the claim by collecting repair data for that model of copy machine in, it says 30, but there's a typo in your book maybe, 40 different regions of the country. The means of the numbers of copies made before the copier needed maintenance for each of the 40 regions have been sorted and are listed in the table below. So if you look at this table, there's actually this whole problem is riddled with typos, and so is your answer key. Sorry. But if you look at this, it says there's 40, and if you count these numbers, 1, 2, 3, 4, 5, 6, 7, 8, and across is 1, 2, 3, 4, 5. So you know there's 40 numbers. And then it says, what are the upper and lower 5% bounds of the sample-to-sample variability, and predict the number of copies that can be made before a machine requires maintenance. Do you think the consumer research group will dispute the company's claim? So it looks like I already did this problem in class, and that's why I wrote all over my book. But so I'm going to use the answer key and do this problem again on a recording. So the first thing they want to know is what are the upper and lower 5% bounds. Okay, so you have to know what they're talking about. So upper and lower bounds, when we're looking at this kind of data, we want the middle 90%. So if this is 100% all the way across, the middle 90 is going to leave, 10%, 5 on each side. So that's why they're talking about the upper and lower bounds. So this would be the lower bound and this is the upper bound. So what this is modeling is that if I took all the numbers from least to greatest, and there's 40 numbers, if I listed them all from least to greatest, and if I got rid of the 5%, like the lowest 5% and the highest 5%, that gives me my middle 90. And so these cutoff marks are the bounds. So let's look at this. So first of all, we have to figure out, these are listed from least to greatest. And if you look carefully at them, they go down. At first I was checking to make sure they don't go across. They don't go across, they go down. This is the very smallest number, and that's the next smallest, they're getting bigger and bigger like this. They're going this way. This number down here should be the biggest number. There's 40 numbers. I want to know what 5% of 40 is, because that's where I want to get my bounds. I need my lower bounds and my upper bounds. So how can I find out what 5% of 40 is? I need 5% of the 40 numbers. So I can say that's 0.05 times 40. And that's, I think I'm going to get 2. That's 2. So that means that 5% of 40 is 2. So that means I want to cut off these two numbers and these two numbers to get my middle 90%. Okay, if I get rid of those numbers, then I'm going to have the middle 90%. I got the 2 lowest numbers and the 2 highest numbers. Now, my bound is going to be exactly right in between the second and the third number. So what I have to do is find out what number is exactly in between 24,574 and 24,600. So I actually can just find that number by adding them together and dividing by 2. So do I have to write that all out? I'll just show it on my calculator. Okay, we're finding the middle in between these two numbers, right where that line is. That's the middle number. So we're going to go 24574 plus 2, 4, and then divide by 2. We're averaging them. And that's where this number came from, 24,587. And again, I can do it over here. And if you really need to see what the math looks like, oh, and by the way, there's a typo in your book again. If you want to see exactly what the math is that gave this number, it is this. Ah, 25033 plus this number. Okay, if I put that in my calculator, I get this. That's where this number came from. So this number is my upper bound, and this number is my lower bound. It's the place where I chopped off the 5% off the two ends. Okay, so that's why when I look in the answer key, it's asking me what are the upper and lower bounds. So, and we won't talk about the mean yet, but the upper bound is 25,037, just like we said, and the lower bound is 24,587. You get that by the process that we just went through. So now how did they get the mean? And by the way, there's a typo, and they put an extra 1 on it. The mean is when you add up all those numbers and divide by how many numbers there are. Well, we know how many numbers there are. There's 40. And we actually know what it would equal if they were all added up, because this thing down here that says checksum, what that means, checksum means that if you add all these numbers up, that's the sum. So I'm going to get my average just by putting that in my calculator. Oh, I put the wrong number. 992,440. And I'm going to divide by however many numbers there are. Well, there's 40 numbers. And that's where they got this number. Okay, that's the mean. So let's get something written down here. So we've got the mean is and then I'll say upper bound and lower, I'll put the lower bound first. So we already said what the upper and lower bound were. We found them by chopping off the extra numbers, the low 5%, and it was lower bound was 24,587, and the upper bound was 25,037. And then I need my margin of error. So margin of error, and you can find this in your book. It's actually on the opposite page. It's on page 292 right there. See how it says margin of error right there? So margin of error is half of the spread between the upper and lower bounds. So I can figure out the spread between the upper and lower bounds because I know my upper and lower bounds now. So the spread would just be minus, and I need half of the spread because that's what it says. And you can read, if you don't understand margin of error, please, please, please just take like 5 minutes out of your day and just read all these words right here. Read all the way down. Set aside some time and read it. And it will tell you everything that I'm saying in this video. So if I do this math right here in my calculator, this is the upper bound minus the lower bound and divide by 2, then I'm going to get my margin of error. I got 450 right here, and then divide by 2, that's 225. So now that I have a mean and I have a margin of error, I can say that this data that I have, it's 24811 plus or minus the margin of error. So in my confidence interval, I can add 225 to my number and also subtract 225 to my number to get like a nice interval, a confidence interval. So when I subtract, then I get 24,586. And then when I add, I get 25,036. Okay, so that's helping me answer all the questions. And if you don't remember what the question was, it was what are the upper 5% bounds, upper and lower 5% bounds. So that was these two numbers that we just found out. Okay, and we just went over how to find those. And then it says predict the number of copies that can be made before a machine requires maintenance. So since I got the mean and the margin of error, and so I'm predicting between 24,586 and 25,036 copies will be able to be made before the machine needs some maintenance. Do you think the Consumer Research Group will dispute the company's claim? So the company is claiming that they can go for 25,000 without getting any maintenance. So 25,000 is within my confidence interval, but they're they're putting it all off to the high side because they want to make their copier look good. But still, I would say that their claim is valid. Here's what the answer key says. It says the interval of confidence, that's what we already got that. It says 25,000 copies is within the machine company's claim. They may also state that one copy machine company is pushing, that the copy machine company, they're kind of pushing the limit with a claim of at least 25,000. Because really 25,000 is kind of pushing it. Like, it's kind of almost, it's getting very close to the outside end of our interval there.